How do you turn this into this? Most students take 10 minutes and many steps to solve this type of question, but today I'm going to show you how to do it in just one step and finish under 2 minutes. In an exam, time is marks. Save 10 minutes and you could gain up to 15 marks. That's why this strategy is a game changer. But here's the catch. If you apply it wrongly, you'll lose those marks just as fast. That's why in this video, I'll walk you through why most students waste time on these questions, the fastest, safest way to solve them, a practice question for you to try, and finally a step-by-step walkthrough of the solution. One important tip before we start, the link to the worksheet is in the description below. But don't worry about copying down the workings. While I explain, just listen and focus. When it's time for practice, I'll ask you to pause the video and try it yourself. Ready? Let's get started. This is a working backwards question. How do I identify it? The question doesn't tell you how many passengers there were at the beginning, and it only tells you how many there were at the end. And they ask you to find how many were there at the beginning, so you'll have to work backwards. Now, what do most students do and why is it such a waste of time? Firstly, most students think to themselves, I do not know how many passengers there were to start with, but I do know how many there are at the end. So why don't I start from the number of passengers at the end and work backwards, which also involves reading backwards. So they go backwards along the sentence and say, oh, 20 people boarded the bus. So sometimes they make the mistake of adding 20, but you're supposed to subtract it because you're trying to find how many there were before these 20 people boarded the bus, right? So they say, okay, let's read the question backwards. Half of them alighted, so they're going to take 15 times 2, and so on. Now, I can't even begin to start reading it backwards because it's going to be very risky. If you do that in the exam, there might be a high chance of careless mistakes. Not to mention, if there's a much smarter way to do it, why risk it? Now, another way that some students use is algebra. They tell themselves, since I do not know how many passengers there were at the start, why don't I let it be x? So let's start with x. We say that, okay, let x be the number of passengers at the start. And they start with x. They say that at the bus stop, a quarter of the people alighted. All right, if a quarter of them alighted, if I were to just draw a quick model, 1/4 of them alighted, it means that I have 3/4 left. So I'm going to multiply by 3/4 to get 3/4 x. You can already start to see how complicated this is going to become. And guess what? I didn't leave that much space for us to do such long workings because I know we can solve it in one step. Let's see how we're going to solve it in one step, shall we? Now I've prepared this. This is the blueprint for working backwards. And don't worry, in the exam, I do not expect you to draw perfect circles like me because I'm using an iPad. So just draw circles like that with your free hand. Okay? You can choose to draw rectangles, it doesn't matter, but you have to label it properly. Now just ignore these arrows. I'll tell you what they are for later on. We'll start with, now each circle represents the number of people that are in the bus at any given point in time. This is at the interchange, okay, at the bus interchange. So how many people were there in the bus? I don't know. Let's leave it blank, shall we? But we do know that a quarter of them alighted. And if 1/4 alighted, 3/4 remain. So for example, you have 100 people in the bus. 1/4 alighted, you're left with 75. How are you going to get 75? You have to multiply it by 3/4. I've drawn the model just now. I can draw it again. If a quarter alighted, you have 3/4 remaining. So we must make sure to multiply by 3/4 in order to get the correct number of people left over. Okay? So after a quarter of them alighted, they say 6 people boarded the bus. So let's add another 6 people. At the end of at the second stop, half of them alighted, which leaves half remaining, and 20 people boarded. Can you see how fast we are doing this? It's going to take less than 2 minutes to solve this question, okay? If you are well practiced, you can do it in under a minute. Now, students, do you know that what do I want to say? Isn't this much easier than reading it backwards? Do you notice we are reading the question forwards? I'm just highlighting the numbers as we go along, right? And we're already almost at the end of the question, almost at the end of the solution. Now, we have 35 passengers remaining, and this is what the arrows are for. We are about to work backwards. Ask yourself, what is the opposite of plus 20? Minus 20. What is the opposite of times half? Now, if you want to know what the opposite of times half is, most of you will tell me the opposite of times is divide. Sure, I will not disagree. You're right. But whenever you see a divide in a fraction, what do? Let me tell you, KFC. It's not Kentucky Fried Chicken. It means keep, flip, and change. Keep, flip, and change. What does keep, flip, and change mean? For example, 1 divided by half equals to, let's keep the number 1. Let's flip the fraction 2 over 1. And let's change the division sign into multiply. We will end up with times 2. Do you notice we are multiplying it by 2 right now? So what is we'll end up with 2, right? So do you notice that divided by half has been changed into times 2? So the opposite of divided by half is times 2. Now, technically it is 2 over 1, but we all know that we do not need to write the denominator if it is 1. Okay, and the opposite of plus 6 is minus 6. The opposite of times 3/4 is divided by 3/4, but remember KFC? KFC, Colonel Sanders says that all you need to do is flip the fraction upside down. Okay, there you go. Let's work it out. 35 minus 20 times 2 minus 6. And I think we need to do some workings for this. 24 times 4 over 3. Let's simplify before we multiply. Simplify before you multiply so that you don't end up with huge numbers. Can you imagine taking this times this? You get 92 or 96, and then you divide it by 3. Isn't that a big number? If you can make it smaller, why don't you? Divide this by 3, divide this by 3. Every numerator can be simplified with a denominator. Okay, so simplify it. You have 8 times 4, which is 32. We have found out that there were 32 people at the bus interchange at the beginning. There you go. How long did that take? I'm sure it was way below 2 minutes without my explanation. If you're doing it on your own, master this technique, you can get it under 1 minute. But let me warn you, there is a pitfall that a lot of students fall into. What is it? They see 1/4 and they immediately multiply by 1/4. Right? Now, half is fine. Half is fine because when half of the people alighted, there's still going to be half remaining. So even if you don't understand what you're doing, copying down the fraction half will not cause you to get it wrong. But anything other than half, you'll end up in trouble. So you must always ask yourself, you must always tell yourself that the circle represents the number of people remaining inside the bus, right? So if 1/4 alighted, then 3/4 remain. Do not write 1/4. 3/4 remain. Okay, now that you know how to apply the strategy, I've prepared some circles and arrows for you. Practice question is a little bit more challenging, okay? You'll require 7 circles this time because there are more steps involved. And one more thing, you'll need to understand what the question is saying. Things like $12 more than 1/3. What does that mean? How are you going to represent it on your diagram, right? $14 less than 3/4. You need to be able to understand the phrasing of the question. So at this point, I'd like you to pause the video, think about it, try your best to solve it. And when you're ready, unpause the video and we'll go through the steps together. Go on. All right, looks like you've tried the question out. Let's see how to solve it, okay? Firstly, I would like to ask you, what's the meaning of $12 more than 1/3? Let's draw this. If I have some money, then I divide it into 3 units. This will be 1/3 of my money. So 1 unit is 1/3, right? If you say that I'm spending $12 more than 1/3, I'm going to take an extra $12. So this is the total amount of money that I'll be spending. which is 1/3 plus $12. So how do I represent this on my diagram? Look, we start with a certain unknown amount of money. Then I'm going to spend $12 more than a third. Once you spend a third, okay, once you spend 1/3, what do you have left? Let's say we spend 1/3. We will have 2/3 left. So let's take it step by step. We are going to have 2/3 left, and we are going to spend $12 more than 1/3, meaning that we are going to deduct another $12 from our savings. Okay? So this is how you can visualize what's happening. Let's do more so that you'll get more familiar with it. $14 less than 3/4. So again, if you would like to visualize it, you can draw a model. If you don't need to draw a model and you can visualize it, that's great. But for the sake of explanation, I'm going to draw a model. They say I'm going to spend $14 less than 3/4, right? This is 3/4. If I spend 3/4, I will have a quarter left. So let me multiply it by a quarter. I have only 1/4 left, but I'm spending $14 less. So I'm actually saving more money. I'll end up with more money, right? So I'm spending $14 less. So I'm going to save an extra $14. Even if you don't draw a model, it is pretty logical. If you spend less, you're going to save more. So just give yourself $14 more to spend. And let's read on. At the third shop, he spent $10 more than 2/3. Now, if I've spent 2/3, I'll be left with a third. And if I spend $10 more than that, I'll have less money for myself. So I'm going to deduct $10 from my savings. And finally, I have $5 left. I'm almost broke by the time I finish shopping. That's what shopping does to everyone. So it's time to work backwards, students. How much money did you start with? Let's do the opposite. The red arrows are for you to work backwards. Ask yourself, what's the opposite of negative? Positive. What's the opposite of multiplication? Division. But remember what Colonel Sanders said? He says, flip it upside down. But you don't have to write the denominator. If it is 1, we'll just write 3, okay? Minus 14 times 4 plus 12 times 3/2. Let's get rolling. 5 plus 10 times 3 minus 14 times 4 plus 12 plus 12. And times 3/2, 136 times 3/2. I'll do a little bit of workings here. I'm going to simplify before I multiply. Divide by 2, divide by 2. Okay, so 68 times 3. That will give me the original amount of money I started with. How do I do 68 times 3 mentally? I'm going to split it up. 60 and 8. Multiply both by 3. I'll get 180 here. 8 times 3 is 24. Then you add them together, 224. Okay? So that's the amount of money I started with. But are they asking for that? The question is actually asking, how much money did Noah spend on the pair of shoes? All right. Now we'll have to investigate where he spent money on shoes. Where did he buy his shoes? Let's see, a pair of shoes. He spent it at the second shop. And at the second shop, what did he spend? He spent $14 less than 3/4. And where is that in the diagram? I would say it starts from here. So before he enters the second shop, he had $124. Then he spends 1/4 and $14 more. By the time he gets out of the second shop, he only has $45 remaining. So all you need to do in order to find how much the pair of shoes costs would be to find the difference between 124 and 45. So he went in with $124. After buying the shoes, he only had $45 left, which means that the shoes cost him $79. There you go. Now, students, Can you imagine if you had used algebra? Or if you tried to read this question backwards, how many mistakes would you have made, firstly? Secondly, would you have been able to figure out how much the shoes cost as easily as this? With this diagram, we just took two circles, we found the difference, and boom, we have the answer. And that's how we solved what looks like a 10-minute question in just one step. Imagine saving that much time across section C. That's an extra 10 to 15 marks in your hands. One step, 10 extra marks. That's the power of the right strategy. This is only one of the 28 effective strategies and tools my students use to solve problems with speed and accuracy. So follow me for more powerful techniques. And if you want to learn how to apply this and other strategies in real exam-style questions, sign up for a free trial with Qtify Education by clicking the link in the description below.